In stats, we started by looking at a two-prop z-test. So that is a two-sample z-test of proportions. You are A-OK to write for the name of the test what the calculator says, and that is a two-prop z-test. When we do this, just like a two-sample t-test, we need to define P1, the true proportion of whatever. And define P2, the true proportion of whatever. Remember, those are our parameters that we're estimating. And then for our null, we're just going to assume that the two are equal, that there is no difference between the two. And for our alternate, we are going to suspect that one is smaller than the other, or just not equals. One of those. There must be some randomness in there. Both samples need to check out with the large counts test. So this is a little annoying because you have to check 4 things. So there's for sample 1, but you need to check sample 2 as well. So all 4 of these need to check out, and you got to show it. And then you can say sampling distribution is approximately normal. But you got to check all 4. We have a new formula for this test, which, by the way, you can still just write the name of the test instead of writing the formula. But in case you're curious, that formula is z equals P1 hat minus P2 hat minus the hypothesis, which is likely to be 0 because you're assuming that there's no difference between the two. And then the standard error, which brings in a whole other proportion. And that's typed at the bottom of the screen. I'll talk about it here in a second. So there's our formula. PC, that's the combined proportion. That's all the successes added together for both groups and both sample size added together. It's the combined proportion. Your calculator does every bit of all of that. We'll see it in a second. You don't have to have those memorized. Pieces of these things are typed on the formula chart, so that's handy. But otherwise, you're just copying output from the calculator down and defining your groups and concluding. All right, let's try one. So we have a problem here about warts. Did you ever think you'd talk about warts in math class? So sadly, there are some patients with warts. They assigned them to 2 groups randomly. So right there, that's kind of nice. They'd had random assignment. They went and do a duct tape group or a freezing treatment. That duct tape group sounds pretty horrible, what they had to do. You would think duct tape is better because duct tape fixes everything, but I don't know if I'd go through that process. So let's run a test. One thing I do want to point out, I should have probably changed this wording to do the data suggest significant statistical evidence that freezing is less successful. So notice how it's vague. It doesn't say to do a hypothesis test. It's implied. All right, here we go. State step, define your groups. We are talking about the true proportion of successful, let's get rid of that. That's in the way. It's going to confuse people. Of successfully removed warts when using liquid nitrogen freezing. And then group 2, duct tape. True proportion of successfully removed warts when using duct tape. So this is a hypothesis test. Notice they don't ask us to do an interval, so it's implied that we need to do a hypothesis test. For HO, we're going to assume that the two proportions are the same, no different. And for HA, we suspect, want to test if duct tape is better. I didn't see an alpha value in the paragraph, so we're going to let it be 0.05 and move on to the plan step. Patients were randomly assigned to treatment groups. But they weren't random samples. They were all just patients, and I guess they randomly decided how to treat them. These 4 things need to check out. And I love it when they present the data the way they did, right above my work here. Because when they present it that way, we don't even need to grab a calculator. We can just see those successes and write the results down. So I always write this down. But you don't necessarily need a calculator, because you know that 100 times 60 over 100 is 60, right? And the other has to be the number that adds up to 100, so 40. For group 2, you know that's going to be 88. And if you don't know, type them in and you'll see it's 88. For the other, whatever number adds up to 104, so 16. And we can say sampling distribution is approximately normal. All right, moving on to the do step. We are going to do a 2-prop z-test and grab our calculator. And it will do all the work for us. So in the calculator, you go to a blank screen, press Menu, Stats, Stat Tests, and we want 2-proportion z-test right here. If you accidentally click 2-sample z-test up there, I mean, it's not the end of the world. You'll see right away you don't have what they're asking for, so hopefully you back out of that and you pick this one. For this one, we have 60 successes. We have 100 people. We have 88 successes, 104, and we think group 2 is larger. And that's it. The Inspire is really nice because it tells us the p-value right here. The 84 is tricky because it just prints a p, and it's easy to mix it up with this p hat down here. So that p hat is the calculator's PC, that combined proportion. If you add up all the successes divided by all of both samples. So it's all here, it's just you got to know what you're looking at, and the critical one is p-value right there. So back to the problem. Let's wrap this up. I typically just copy everything down unless I've already written something down. So I know that P1 is 0.6. I know P2 is 8462. I know PC in the calculator is just that plain P hat. You don't have to write it like that, but just to point it out, it is 7255. The Z is negative 3.9383. And then you can just write p-value is about 0. You could write it equals 4 zeros and then a 4. I personally like to write the p-value like this. But that's just me. And then obviously p is smaller than alpha. All right, let's conclude. We reject HO because p is less than alpha. Evidence suggests the true proportion of warts successfully removed for the duct tape group is greater than liquid nitrogen freezing group. All right, hopefully that made sense. I'll see you in the next video.